Hello everyone, welcome to today's webinar sponsored by Hazelcast and InfoQ. My name is Srini Penchikala. I am the lead editor at InfoQ for the AI, ML and the data engineering community. I will be the moderator for today's webinar. Today we are going to hear from Johnson Noel from the Hazelcast team. The presentation title is Streaming SQL on Apache Kafka for real-time processing. Let me introduce our presenter first. Johnson Noel is a senior product marketing manager at Hazelcast. He has 30 years of software industry experience, ranging from pre-sales, architecture and design, business analysis, and implementation and operations. Most of his time has been focused around database-related technologies. Johnson, welcome to this webinar. Hazelcast is a streaming data platform that supports diverse design patterns for the data ingestion, processing, and analysis of streaming data in real time. In today's webinar, Johnson will discuss why streaming data processing is critical in today's data architecture initiatives and how to process the data in real time using an emerging dialect of SQL, informally called the streaming SQL, which is used to add context and meaning to enrich the data. So before we go to the main presentation, I would like to go over a couple of housekeeping items. The main presentation will be about 30 to 35 minutes long. After that, we will have a 15 to 20 minutes Q&A session where the presenter will respond to questions from the audience. I'll be moderating the Q&A throughout the presentation. If you have any questions during the talk, please submit them in the Q&A window on the webinar screen. So you can see the Q&A section on the screen. Everyone's microphones except the speakers will be muted by default. The recording of this webinar will be available in next couple of days to watch it offline. You will all be receiving an email with more details on that. I think that should be all for the housekeeping items. Johnson, I'm going to turn it over to you now, and I will turn off my video. I am very much looking forward to the presentation. Please go ahead.
Thank you very much for the introduction, Srini. Hello everyone. My name is Johnson Noel, and as Srini mentioned, I'm going to be talking about streaming SQL on Apache Kafka for real-time processing. So we are going to discuss how you can use a form of SQL called streaming SQL to run queries against live streams of enriched data in real time in order to gain immediate value and insights. By way of an agenda, we are going to cover the following. We'll start off with introducing the idea of real-time data, what it is and why it's so relevant now more than ever. We're going to discuss some of the challenges that real-time data poses, and then we'll look at some of the opportunities that it presents modern businesses. Then a swift overview of Apache Kafka. I'm making the assumption here that most people are familiar with it, but just in case, bearing in mind that it is a key protagonist of this discussion. And then we'll look at a typical streaming SQL architecture and talk through a typical data flow. Introduce streaming SQL, what it is and how it's different to traditional SQL, and then share some examples of how you can use streaming SQL to manipulate data in motion and combine that with data at rest in order to enrich that data. And then towards the end, we'll introduce the idea of a combined stream processing component and in-memory store, effectively how Hazelcast addresses the challenges that we'll be discussing, as well as looking at a reference architecture for stream processing, and then I'll wrap up with a couple of use case examples. So, okay. Real-time data, right, why is it important? So, real-time data is important because it's a critical component of any modern business, and there are potentially huge rewards for those who choose to follow this path. And simply put, real-time data lets you act on information immediately as it's unfolding. So let's just look at this for a minute. We all know that the pace of business has massively increased. You know, every time we look, it gets faster and faster because people don't want to have to wait. So having access to information that enables you to make decisions at the speed of business can give you that competitive edge. And, you know, consider remote and global international teams who have to provide follow the sun support. Having the best information in real time means that your business is always up to date. And that means decision making 24/7, 365. Being able to swiftly to respond to faults and operational issues as they are happening stops the rot. Without real-time information, it could be hours or even days before you detect the problem. And having to roll back or undo processes would obviously be very costly. And what about industries that are sensitive to market changes or fluctuations, like the stock market? Real-time data is absolutely essential to a business's survival. You know, anything less is not an option. And, you know, imagine if real-time data could help you identify customer preferences, whether it's, you know, creating an environment that encourages the customer to purchase more or feel like they're being treated as an individual, for example. You know, that could significantly improve your business's fortunes. And so these are just some of the very few, you know, just some of the very many examples. And, you know, I'm sure everyone can think of use cases that would significantly, you know, benefit their businesses or some aspects of their lives. And so a characteristic of real-time data is that it's generated dynamically when an event occurs, and it's an unbounded flow of information relating to a business operation. And, you know, this information can come from a variety of sources. It could be social media, website activity, geolocation tracking. And so you can imagine that there is a huge amount of data being generated. You know, think about every transaction process that you can think of. It could be a payment, a sale, sensor reading, a machine status update, for example. Huge volumes, and in many cases, you know, very high velocity. So from terabytes to many petabytes in, you know, a very short period of time. And because that data comes from all different sources, you can imagine that it will have different formats, sizes, and in many cases it will be raw data. You know, it could be just be you know, a record acknowledging an event with very little context, and so that data alone cannot deliver high value or insights to a business, because, you know, it'll be probably quite difficult to understand or decipher. And so in many cases you may well find that some of this information is already being stored somewhere, but not realizing its value. You think about the systems that you're working with, there's probably terabytes of data being, you know, continuously generated, and no one's looking at it. And, you know, that's because managing real-time data can actually be quite hard. But so modern businesses see huge opportunities with real-time data, and they know that they can gain competitive advantage over their competition, and or indeed, you know, improve operational efficiency, because they're making faster and better decisions. They're better informed, and as they have up to the second information, you know, they can you know, understand you know, events unfolding as you know, as they're actually happening in real time. And so real time can drive innovation in pretty much any industry. You know, I could just pick a couple, for example. You know, let's talk about healthcare. You know, imagine being able to predict peak patient utilization levels so that you can optimize staffing, or perform real-time diagnostics for illnesses, or in finance, managing fraud detection and payment processing, or even supply chain, reducing freight costs or improving supplier delivery. You know, and so overall, real-time really lends a hand to drastically improving decision-making, because you get the information immediately, and then you get it with meaning and context, you know, if you've enriched it with reference information. So we're just starting to get into the area of continuous query with SQL, and before I do that, I just wanted to just do a quick overview of what Kafka is, and I'm pretty sure that the vast majority of you will be familiar with what it offers. But I'm just going to quickly whiz through this, as I think, as it's one of the main characters in this talk, this would be handy for anyone who's unfamiliar or needs reminding. And so, Kafka is a distributed event store and streaming platform, and it's designed to allow your applications to process records as they occur. We know that it's being used to handle real-time streams of data and perform real-time analytics on data, and it has excellent performance, it's highly scalable, durable, and fault tolerant. And so, Kafka also has an operational simplicity. It's relatively easy to use and set up. And of course, the use of Kafka is actually, it's exploding. More than 1/3 of all Fortune 500 companies use Kafka. These companies include the top 10 travel organizations, 7 of the top 10 banks, 8 of the top 10 insurance companies, the likes of LinkedIn, Microsoft, Netflix. They process a lot of their data with Kafka. So this diagram, I guess, represents what is known as the Kafka architecture. And, the Kafka architecture is a software architecture used for processing stream data. And, it supports near real-time analytics when the data is read and transformed immediately after it's inserted into the messaging system. And, this makes recent data very quickly available for end user queries. So just looking from the left here, you can imagine over here, you could imagine some kind of smart devices. Here we've got like trade information coming in. It could be business applications, service updates, machine sensors, producing real-time events as they're happening. And so, this information is actually being pushed through Kafka and ingested into some kind of, stream processing engine where there's some kind of, data extraction, joins, merges, and aggregations that are actually being performed. And, in Kafka, the data resides in topics, and each of those topics can be viewed as tables, and you can now join those tables together or join them to tables in your reference data store to add meaning, context, and truth to that data. And this is important because there's limited value in doing all of the work around transformation if you can't reference it against information that adds context and meaning in order to produce more accurate and true information. So the reference data is absolutely essential. And so you can run, streaming SQL queries, to analyze that data, and on some platforms even run machine learning models. And so you can push that data to other applications that might be participating in some other kind of workflow process, pushing to alerting and operational monitoring systems, populating visual dashboards, or triggering actions and feeds into systems of record, and you can deliver in real time. So you are drastically increasing the chances of making much better, faster decisions, leading to better business. And so, to summarize, there's nothing in this window on this slide which is optional. All of the components are mandatory. They're essential to be in this diagram in order to really implement a typical SQL streaming architecture. So streaming SQL, what is it? So there are some similarities to traditional SQL, but it's SQL for stream processing, and it allows you to enrich, filter, join, and transform from multiple data sources. And those data sources can be both in motion and at rest, and the query values are continuously updated in a result set based on a specific criteria. So using something which is called a materialized view, a temporary data structure that resides in memory. And so streaming SQL is popular because it offers non-developers access to streaming data, something that wasn't previously available. So all of your valuable business data can now be shared across a broader reach of users. And what that means is it's a greater opportunity for more people in your organization to make better business decisions with real-time augmented data. Another key difference between continuous SQL and traditional SQL is the way in which the results of the queries are handled. So In traditional SQL, a result set is returned to the calling application, as a cursor consumes the results. Using continuous SQL, the results are continuously returned, as mentioned earlier, to sinks. So sinks can be streams of data, such as Kafka topics, or sinks can also be more traditional systems, such as relational database management systems. Creating a materialized view on a stream is one of the important and sometimes tricky and overlooked parts of streaming data pipelines, but it's absolutely critical to success. So for example, you think about IoT sensors, transmitting continuously updated event data, maybe for things like latitude and longitude. This materialized view would give you the latest message containing the latitude and longitude information, and not the coordinates of the previous locations. This enables companies to get the latest snapshot of their information, so that they can make immediate, informed decisions. So one of the key differences between traditional SQL and streaming SQL is you might want to, if you're handling a continuous stream of data, you might want to perform queries against it. And so windowing enables you to assign events into time-based windows. So with streaming data, as it's common, to group data in relation to time, whether it's performing aggregations on, a data stock trade information that you need to group over the last 5 minutes, for example. And so in this example, we have, two types of windows. We've got tumbling windows, and tumbling windows assign events into non-overlapping windows of a fixed length, whereas at the bottom we have hopping or sliding windows, and these assign events into overlapping windows of a fixed length, where you can define the distance between the starts of two consecutive windows. In other words, the actual hop size. And I'm going to show a couple of examples shortly. So generally speaking, streams usually contain information that changes with time. And in this example, we're looking at trade data, so prices, quantities, and sales. But there are times when you may want to enrich the stream data with static or infrequently changing data, such as some kind of label or organization structure, or some sort of characteristics that will help describe the data. In this example here, you can be ingesting trade data, for example, from a stream processing component, and enriching the trade information with company data. So, looking at this statement here, the trades is a Kafka topic, and companies is a table in the reference source that has a stock symbol information that you might want to join, so that you can present that to a dashboard to give the users more context around the trade information. And so you can run this query that joins information from a Kafka topic with the data in your reference store. And so this gives you this augmented picture about potentially all of the trades that have been running throughout the day. So let's just take a look at some examples. So we talked briefly about tumbling windows, and we mentioned that a tumbling window, you're defining the length of that window. So let's say that you have a tumbling window of say 2 seconds. What this would mean is that it would read 2 seconds of data, and then it would read the next 2 seconds of data, and then the next. So you have distinct exclusive windows that are consecutive. And so if there's any time that you might want to, break up data and query by, one window at a time, a tumbling window could be used. And, just looking at this example here, you could imagine that we might have created some kind of map into Kafka, and so we are inserting, some values into a stream. You can see here that, we've specified that we're going to use a tumbling window here, and then, we're selecting from the window start and the window end position, and then what we're going to be doing is we specify a particular criteria, and then we're grouping by window start and by by window end. Here we've got another example. So this is a hopping window. So here you would also define a fixed window, but the location of that window moves. So, using the earlier example of a 2-second window, a hopping window would actually give you a more granular, a greater level of granularity, in terms of the incremental changes in which to view that data. So you could gradually slide over the window rather than in whole chunks. So you're moving the window incrementally, and there could be many use cases that you may want to use that for. So again, in this example, we're selecting from the start and end positions. We're pulling in information from a key where a particular criteria is met, and then we're grouping by window start and by window end. So the examples that I've just shared are examples that we can run in Hazelcast, and so Hazelcast is an open source cloud ready real-time data platform, and you can build and deploy applications that require high throughput and low latency. So you can unify continuous streams of live event data with context that's derived from both traditional data sources and other continuous data streams. And so this architecture gives the ability to acquire valuable insights, and that can lead on to operational efficiency, gaining competitive edge, business advantage, for example. And so this is what the Hazelcast ecosystem looks like. So you have Hazelcast in the middle, and then all of these supporting components around it. And so we've got this integrated in-memory store and stream processing engine. So you have the ability to perform real-time streaming and batch within one single technology stack, and we have benchmarks that prove that you can run very heavy workloads on this type of architecture on less than a third of the hardware of all alternative solutions that are not integrated. So really talking about much greater efficiency and a strong price performance advantage. And so in addition to performance and efficiency, we deliver high availability, vertical and horizontal scalability, and a comprehensive built-in security model. And so it's an enterprise platform that's extremely portable, enabling you to deploy on tiny devices all the way to the cloud. And so just looking at the system reference architecture, you can see how the system components interconnect, as well as how Hazelcast fits into this picture. So on the left here, you can see that we have Kafka, and obviously it's being used as the event store mechanism, capturing data from the streaming data sources, and that is a continuous feed of data from whether it's log files, social media feeds, smart devices, and so forth. And then Hazelcards then read the data from Kafka using Hazelcast connectors to ingest the data. And so, here in the middle, we can see, Hazelcast where, extract, transfer, and load and other processing can take place, like aggregation and enrichment. And then, of course, you've got the in-memory component here, which, can be used for fast data retrieval, as, all of this runs in memory. And then you've got this transaction processing application. And, if you want to retrieve, pre-computed calculations and aggregations, where other consumers can actually use that data for whether it's alerting or displaying metrics in a dashboard, for example. And so, just an overview of where Hazelcast kind of fits in the in the streaming SQL Kafka, space. And finally, just looking at some popular use cases. So, for example, real-time ads based on clickstream. You can, with real-time data, you can detect user behavior in a website or application by, analyzing the sequence of clicks a user makes, the amount of time the user spends, where they usually begin their navigation and how it ends. And, by tracking this user behavior in real time, you can, update recommendations and increase, the chances of, retaining their business, for example. And, IoT, Internet of Things is continuing to gather momentum. Smart cities, for example, is one area that has taken off. So, you can imagine enabling real-time monitoring by, pulling in data from all sorts of different places and, standardizing or canonicalizing that data, merging it with reference information to add, information that would give you a real-time view of what's happening and how it's happening in any given location. So you can think about, pulling in data from social and demographic data, satellite images, integrating that with existing reference information and pushing that out to other services. You can imagine enabling workers to perform effectively and safely, if there's maintenance or repairs that need to be done, perhaps building real-time workflow systems guiding workers through their tasks, building alerting systems that would identify problems and provide context or peripheral information that could provide, more accurate information or the truth to any event. So, pulling data from geolocations and meter readings. And so, the real value here is, real-time data is here to stay. Lots of businesses are really focused in on building, real-time solutions, and by having the ability to use SQL means that, as I mentioned earlier, you can broaden the reach. You can, give real-time information to more people so that more people can actually take actions on, real-time information immediately, resulting in improved, business opportunity. So I've finished my discussion. I hope that you've found that useful, and I'm happy to take any questions.
Thanks, Johnson. Excellent presentation. Thank you. I don't see any questions, but let's make sure that we can give some time for questions. Anybody who have questions, please post them in the Q&A questions section on the screen. We will definitely answer as many questions as we can. Actually, I have a couple of questions. We can start with those, Johnson. So can you talk about Hazelcast platform architecture? It has the in-memory data storage and also the compute side, batch and streaming data processing. But coming from the application development side, what kind of support it provides for microservices and the serverless based applications?
Yeah, so we have many customers who so the microservices architecture is obviously an architecture that many businesses are looking towards, especially as businesses start modernizing their applications. And so Hazelcast is very well suited to a microservices architecture, because it gives you a number of different options in terms of how you might want to build high performance, efficient inter-service communications between different microservices. And there are best practice guides that you can go to the Hazelcast website, and we've got blogs and step-by-step examples of how you might want to build a microservices architecture within Hazelcast. And so we have examples of documentation that will support why you might want to use microservice architectures, and some of the challenges that you might face, and how Hazelcast can address them for you.
And definitely, yeah, it looks like a kind of unified platform for different kind of requirements in the application. Also, from the hosting side, what type of hosting options are available in Hazelcast? Can the solutions be hosted on-prem as well as in the cloud? What kind of options are available for the users of Hazelcast?
Yeah, so Hazelcast, you can deploy Hazelcast on-prem or in the cloud. So you can deploy it on the likes of Azure, GCP, and AWS, and of course we provide a highly available environment. So if you wanted to replicate between one cloud provider to another, you can do that. And you can also communicate with your cloud environment and your on-premise environment, so you can replicate data across the two as well. And then of course we support an embedded architecture as well as a client server architecture. Client server is more suitable for more enterprise based environments where you may want to have some level of autonomy to actually grow the in-memory component, the stream processing component in isolation to the applications. But we have many customers who also embed Hazelcast within their own applications, and they benefit from really good performance, and because Hazelcast is running alongside the application, you get some network performance benefits as well.
Thank you. Also, I don't see any more questions, but I'm hoping that attendees are able to post questions. I don't know if there are any go-to meeting constraints there, but hopefully we can see some questions from there. It's okay. Let's continue with a couple of.
Sorry.
Yes.
Just chiming in. We do have a number of questions in the questions tab. If you are able to expand that, a number of attendee questions have come in.
Yeah, I'm not able to see those, Nitin. So I don't know, for some reason. I don't know. Yeah, maybe you can. If you're able to see them, yeah, you can probably go ahead and.
Sure, I will
ask those questions.
I'll so the first question is from Barry Chen. How does the calculation work inside Hazelcast? Are there many workers, and how do they coordinate with each other?
So just so I can understand the question, so how does the how does the calculation work?
That's correct. Yes. It's a question about how calculation works inside Hazelcast, and are there many workers? I guess sounds like are there distributed workers performing the calculations, or is it a single node? Brian, feel free to clarify. I don't know if that gets the gist of the question over to you, Johnson.
Yeah, thanks, Ethan. Johnson, I think it looks like it's kind of more from a cluster type of deployment. The question is, how does the Hazelcast and Kafka kind of work in a cluster environment, where you have to process the data coming in, but in a more of a distributed fashion, right? So
yeah, so Hazelcast is it supports a distributed architecture. So it's effectively a cluster, and so you have the notion of nodes or members, which are resources that you can group together to form that cluster, and that's how you scale up and scale out within Hazelcast. So Hazelcast distributes data pretty much evenly across all of the actual the nodes in the cluster, and Hazelcast will determine the most efficient way to actually place that data. And so, we have connectors for Kafka and for other, services that will enable you to, simply, if you wanted to configure, Kafka to run within Hazelcast, you can just define that connector, and then Hazelcast can pull that data in and then process within Hazelcast, whether you want to run it from stream processing component, or you want to run against the in-memory store.
thank you. We have a few more questions. This next question is from Francois. I will read the question. So I have never seen hop and tumble as SQL statement functions. So the audience, the member is asking, like, are they supported by major database providers? Or are they custom functions in streaming SQL?
The hop and tumble, they are, I believe, they are specific to streaming SQL. And so, I would imagine that there are other providers that would, support the same kind of model, because, window in is not exclusive to Hazelcast, but, if you get onto the website and you look at the Hazelcast documentation, there are some examples of, if you wanted to do some sort of research around understanding how they work. And if I remember, there's actually, if you go to, the docs.hazelcast.com, there might be an interactive tool that you can actually use that will, create a Docker image and go through a step-by-step process of, how you can actually, run some of those processes as well, in terms of enriching the data, and performing windowing.
Thank you, Johnson. Yeah, with the streaming data getting so much attention and becoming a critical part of the data architecture, right? I think some of these functions, maybe your team is going to lead this effort, but yeah, they will probably become more standard solutions in the SQL-like solution scripts, right? So that other database providers will support as well, because we need some kind of a common standards for these streaming functions. Yeah,
and of course, with Hazelcast, because we've got the integrated in-memory store and stream processing component, you can imagine that windowing, which it requires some resource-intensive processing within Hazelcast, we can perform those very, very quickly.
Yes. Okay. So another question from Barry Chen. He's asking, what will be the limitation of Hazelcast? Is it horizontally scalable while handling huge amounts of data?
Yes. So you can scale up and you can scale out with Hazelcast. So in terms of a limitation, and it's an interesting question, because as of recent, the most recent release of Hazelcast, we've also implemented tiered storage. So now you can grow even larger than previously. In the past, Hazelcast, you were able to store a certain amount of data per node, but with tier storage now, you can grow into definitely several tens of terabytes. So it's difficult to kind of talk about a limitation. I mean, there obviously must be one, but one of the good things about Hazelcast is that as you add more nodes to the cluster, we have got benchmarks that prove that we can grow linearly. So, it doesn't top out. You can just add more resources, and as you add more resources, you can add more workload. So, it's an interesting question. If the gentleman who asked that question, if he wants to kind of delve into that in a bit more detail, I'd be happy to have an offline discussion.
Yes, yeah, makes sense. Sometimes the scalability can be dependent on the software as well as hardware, right? So the infrastructure.
Yeah, and of course, Hazelcast runs completely in memory, so everything gets processed at that speed.
Right. And the same a follow-up question from Barry again. So can you compare Hazelcast to Pino, I think PINOT, or Druid or ClickHouse? So I am familiar with Druid. I don't know these other tools, ClickHouse and Pino, I guess. So how do you compare Hazelcast with those technologies?
I'm afraid I'm not familiar with them. Could you explain what Druid is?
Yeah, Barry, maybe you can clarify this, right? So Druid is one of the data processing frameworks. I don't know about ClickHouse or Pino, I guess PINOT. Never heard of these, but maybe Barry can kind of follow up offline.
Oh, right. So this is, I think this is Apache Druid, is it? It's
yes.
some kind of database or something. So it's a real-time database. I'm afraid I just don't have any information about it at the moment, but I am familiar with what it is. I do understand that
right. Yeah, some of these are new to me also, so I have not heard of a couple of these technologies.
And I'm just wondering. I'm not sure if Apache Druid actually runs in memory, but yes. Right. I'll certainly try and find out.
Yeah, thank you. Yeah, maybe this can be offline kind of follow up. So okay. Next question from Michael Henderson. Does Kafka streaming support SQL, or do you need Hazelcast use SQL with Kafka streams? So Kafka streaming they do have a KSQL, right? I don't know if that is the question here.
So Kafka streams have a KSQL. I mean, we work very, very well with Kafka, as in, in my presentation. I mean, if you think about the architecture diagram that I showed, we are talking about Kafka as in, the event store, as opposed to Kafka streams, which is slightly different. But we obviously Kafka is very, very fast, and Hazelcast runs in memory. So we work incredibly well with Kafka. Kafka streams is slightly different. I mean, that's kind of there are similarities, I guess, to our streaming component, but yeah, that's a slightly different. Well, it's a streaming service, but we interface with Kafka as opposed to Kafka streams.
Right. I think in a way, I think Kafka streams and Hazelcast are comparable, right? Because they both kind of work on the Kafka foundation, and Kafka streams kind of treat a stream as a table kind of thing, right? So I think there is some storage type of comparison.
Yeah, there are some similarities. Right. They're both streaming services, yeah.
Okay, I don't see any additional questions, but yeah, we can kind of maybe wrap up with a couple more questions here that I have on the list, Johnson. So next one is, so yeah, I think this question I wanted to ask you. So like, is it possible to use streaming SQL and traditional SQL in the same query? Like if some of the data that application needs is coming from a Kafka, and some other data is stored in a database like Postgres. So if we want to join the data between those two data stores, what is the best practice? Can we use SQL and streaming SQL combined, or?
Yeah, you can. Yeah, so you can actually join, a Kafka stream, for example, with a relational data structure. So you can imagine that relational data structure might be your reference data. And so that's exactly how you would actually do the enrichment, because you'd be joining, the information that's coming from the stream and then matching that to maybe a key or something that would, add, some metadata that enriches that information so that you've got more context about the actual transaction itself. So yes, you can do that, and and moving forward, you'll be able to join multiple streams in real time, and join that information with external reference sources as well.
Right, exactly. Apache Spark kind of supports this, right? You can actually use Spark streaming and Spark SQL and those other libraries to kind of combine these different types of data. So it's good to know that it is possible. And so, okay.
Yeah.
Sounds good. Okay. Yeah, looks like Barry had some follow-up on that PINO, I guess, if I'm pronouncing correctly, PINOT framework. It's invented by LinkedIn for real-time analytics. So LinkedIn, I know who actually is also the company behind Kafka, I think, right? So, so he was just wondering what are the difference between PINO and Hazelcast. Yeah, he's going to follow up offline, so which is probably a good idea because it is a relatively new tool, so it's not easy to compare, right? So, right.
I think Apache Pinot, I guess it's pronounced Pinot, is some kind of
right.
a distributed OLAP data source of some description. OLAP is so it's an analytical engine, I guess. I'm not sure if we've done any benchmarks against it, but I'd be happy to take that offline and have a discussion with him and try and figure out what kind of use cases he's looking at.
Yeah, so this is a good question. So all of these new technologies and tools coming out, it's a result of how important streaming data processing is, right? And how the in-memory data store and real-time data processing that's available in platforms like Hazelcast, how that is going to be a big difference maker, in terms of processing the data, analyzing it, and making some intelligence out of it, right? So.
Yeah, and I mean the beauty of Hazelcast is that you don't actually have to that data as the data is coming through the stream, you can you can process that data, you can add, you can enrich it, you can build aggregations and do all kinds of processing, whether it's ETL, whether it's denormalizing or anything you want to do with that data. You can actually present the result sets back to the client before it actually touches anything that resembles a persistent store like a database or anything like that. So there's a lot of platforms out there where you actually write the information to a database, then you perform the aggregations and all of the extract, transfer, and load in the database, and then you have to take it out of the database and then push that out. And for every single obstacle that you have to go through, and not to mention latency with IOPS and network transfers and things like that, you can imagine that takes quite a long time to actually get vast quantities of information aggregated and built and pushed back to whoever's requesting it. But with Hazelcast, all of that's done in memory, so it hasn't got anywhere near any kind of persistent store at that point in time. And of course, the great thing about Hazelcast is it's a cluster, so it's highly available, and you can build various levels of durability into it to ensure that your data is always protected.
Thank you. Actually, Michael has a follow-up comment on the Kafka streams question. So I will read his comment here. I wrote a Kafka streams application that reads one topic into a K stream, another in a K table, and joins them to produce a new K stream. So now I have to add windowing. So he's asking about windowing function. So not happy with the performance. The way he's doing it right now looks like it's not performant. So Hazelcast would be an alternative way to do this. He's asking like maybe Hazelcast can make it a better solution.
I think he would certainly, yeah, I would definitely say so. I think we've got benchmarks that prove that you can get huge amounts of performance from Hazelcast. We've actually got a benchmark which is online, which is the Nextmark benchmark. So NEXMARK. If you do a search on Nextmark benchmark, it actually shows us running against a it's like an online auction, and we managed to process 1 billion transactions a second, running on 720 vCPUs, and so that's using both the in-memory component and the stream processing component, and that's enriching data as well. So I would certainly recommend at least having a look, and if I'd be curious to find out what the use case is, and so if that gentleman wouldn't mind sharing his details, I'd love to have a discussion with him.
Yeah, thanks, Johnson. Yeah, Michael, please go ahead and reach out to Johnson and the Hazelcast team offline. Also, Nitin posted a very interesting link in the chat. This is again one of the press releases from Hazelcast about how to process a large number of events per second, right? So with streaming solution. So yeah, definitely check out those links.
Yeah, and as I said, if anyone wants to have a kind of a casual discussion around what the capabilities of Hazelcast are, or how they might want to build a streaming service for a given particular use case, then I'd happily just have an informal discussion with them to help them understand exactly what they can actually do on the platform.
Sounds good. Thank you, Johnson. Any I don't see any additional questions, so hopefully we are kind of wrapping up on the questions. So any final kind of thoughts before we wrap up the webinar? Johnson, do you have any final kind of comments or remarks?
No. I think the streaming SQL is here, and as I say, it's the motivation to this discussion was to say, if you're running on Kafka and you want to build real-time applications, you don't have to be a Python or a Java developer to be able to manipulate and get value from data. If you understand SQL, you can also run SQL queries against data in real time and get the same business value.
Yeah, definitely. I think most of the data analysts and data scientists they tend to be not very technical in terms of programming, right? So SQL-like interface is the best way, not only from the ease of use standpoint, but also the faster value, right? So they can see the results right away by running those queries.
Yeah, and even if you don't know streaming SQL, going from standard SQL to streaming SQL is not a big jump. It's you're adding a couple of other dimensions like windowing and watermarks and things like that. But it's still a select statement, and it's if people understand SQL, then they have access to real-time information and make real decisions, act on that data as it's happening.
Makes sense. Thank you. Yeah, Barry is saying that many thanks for sharing this information today. So he will investigate Hazelcast further, to see they can get some more value for his applications. Thanks, Barry. Thanks, Johnson. So that's all we have today. So let me make sure that we have any kind of final housekeeping items here. Yes, I want to thank everybody who has attended this webinar and submitting your questions. Again, dev community and you guys are the main reason why we host these webinar events. We want to share with the developer community the innovations happening in the software development world, and these webinars are one way to share the innovations happening in the technology. So that's all we have for today. Thank you, everybody. Thanks, Johnson. We will see you all next time. Thank you.